torsion equation, and that equation is T by J is equal to G theta by L is equal to tau by R, right? Okay, so this is the question. Let us study this question. Find the maximum stress in a propeller shaft. Diameter of the shaft is 40 cm external, 20 cm internal, when subjected to a twisting moment of this 4650 Newton meter. Okay, you have to find out the maximum stress in this propeller shaft. If the modulus of rigidity G is equal to 82 gigapascal, and then second part is how much is the twist in a length 29 times external diameter. That is the second part of it, right? Okay, so first very important part, friends, for this type of question is please write down complete information given in the question and write down what he is asking. That means 50% of the question is done, right? So in the same manner we did this exercise, and if you compare this, then we made a shaft, internal external diameter written G. Okay, I am sorry, I had written here 20, but it is 82. No issues, I have not done calculations of it, so you will write down 82 only. Okay, then torsion is 4650 Newton meter. Okay, then he is asking find the maximum stress in a propeller shaft. Okay, then second part is how much twist, theta. So torsion equation is T by J is equal to G into theta by L is equal to tau by R, and for maximum stress T by J is equal to tau by R and tau is equal to T into R by J, right? Now in this, what value of R one should choose? This is very important, because as far as J is concerned, we are very clear that for hollow shaft it is J is equal to pi by 32 d to the power 4 minus small d to the power 4, or external diameter to the power 4 minus internal diameter to the power 4. But for R, what value we have to take? For R, it is a thumb rule that will take the outermost distance from the axis, from axis to the outermost fiber, right? So that is R we have to take as external diameter divided by 2, that is d by 2 is equal to 40 by 2. And friends, we have to make sure that we will convert all units. In this term is in centimeter to the power 4. So I had already converted this into meter to the power 4, and on the same line this R also. So if we do so, then we'll get the value of tau, and in this you have to convert this 20 and you will get the answer. This answer is correct, right? Okay. For second part, how much is the twist? So then what we'll do is we'll compare T by J is equal to G into theta by L, and if we do so, we already know T, we already know J, G already given, theta you have to find out, L already 29 into D. So by doing that exercise in this way, we can get the value of theta, and theta will be in terms of radians, right? So very easily we'll get the answer. Please mind it, this 20 will not be there, it is 82 as given in the question, right? So then you'll get the value of theta, but this value will come into radian. This block, if you do the calculation, you'll get something, but that answer will be in radian. You can always leave your answer in radian only, but if you wish to convert your answer into degree, then you have to multiply and divide by these two terms, right? Okay. Second question is about comparison of two shafts, and those two shafts are, in this question what we have to do is we have to replace this is the second numerical of your tute sheet. You can note, you can study that numerical from there itself, but for the sake of time, I had written the complete information whatever is given in that numerical into this paper, right? Okay, so in this what he said is that they wish to replace this solid aluminium shaft, and length of the shaft is 100 centimeter, diameter of the shaft is 5 centimeter, by a tubular steel shaft in which the external diameter of the tubular steel shaft is 5 centimeter only, but internal diameter you have to find out. Please pardon me in this, because in this I had written this diameter as 5 centimeter, and on the opposite side I had mistakenly I had drawn this shape as 5 centimeter, right? So please you kindly take care this, that it should be something like this only, because these two diameters are same, right? Okay, then so you have to find out the internal diameter of the steel shaft, and it is given that the two shafts experience same amount of torque and experience same amount of angle of twist. For solid shaft, for hollow shaft, for solid shaft, for hollow shaft, right? The tubular or hollow, it is nothing but the same. Now if it is given, then we can always apply torsion equation, and in that torsion equation it is written that T by J is equal to G into theta by L. And now what we'll do is we'll see what all different components are same. So T is same, theta is same, and L is same. So T into L upon theta is equal to G into J, right? So then we'll compare G into J of solid of steel and G into J of tubular steel. Now value of G is already given to me in gigapascal. For steel 85 gigapascal, and if I compare, then value of J I already know. For solid is equal to pi by 32 d to the power 4. For this J, pi by 32 capital D to the power 4 minus small di to the power 4, and from this equation we'll get the value of di, right? So it is very simple question, we can always do it, and I don't think that there is any problem in this numerical, right? Okay, let us try to solve third numerical. In third numerical, one more additional point is there. Okay, we can see third numerical, right? So third numerical is a hollow shaft of diameter ratio 3 by 5 is required to transmit 800 kilowatt at 110 rpm. Okay, if I a hollow shaft of diameter ratio 3 by 5 is required to transmit 800 kilowatt at 110 rpm. Okay, let us see. A hollow shaft of diameter ratio 3 by 5, where 3 is the internal diameter, 5 being the external diameter. This shaft can transmit 800 kilowatt at 110 rpm, right? Okay, so this type of information we had already written from the just the first line. So please try this out, huh? Okay, then next line we can study the maximum torque being 30% greater than the mean torque. Okay, hold on, huh? In this it is written that maximum torque being 30% greater than the mean torque. What do you mean by this? What do you mean by this term, that what is maximum torque? See, we mean by maximum torque is that whenever we calculate from the formula of power, power is equal to 2 pi n t upon 60. Actually it is T mean. We don't write mean always, but it is actually T mean. So, and for your benefit, I had written in this, always use T is equal to T mean. But if in any numerical maximum torque is given, then we have to do the analysis for the maximum torque and put T is equal to T max, right? So from this formula we'll get the value of T mean only, but in the equation, that equation is T by J is equal to tau by R is equal to G into theta by L. In that equation we have to put the value of T max. So please study this point. Please make a note of this point, that if in the numerical this type of line is given, that maximum torque being 30% greater than the mean torque or 20% greater than the mean torque, then we have to find out the value of maximum torque, and we have to put the maximum torque as T only, right? Okay, so in this numerical we can always write down T max is equal to T mean plus 30 upon 100 into T mean, or T max is equal to 1.3 of T mean, and then you have to find out the external diameter. Okay, and simple, this is what the torsion equation is, and in this it is given that tau is equal to 56 megapascal, that we can also see in this. And the limit of torsional stress is to be 56 megapascal, so that is tau is given as 56, and modulus of rigidity is 84. Then what is the angle of twist? Okay, sorry. Okay, now so tau is given as 56, and in this T by J is equal to tau by R. From this equation we'll get the value of, okay, now how to solve is, it is T is equal to T max, J is equal to pi by 32, dE to the power 4 minus di to the power 4 is equal to tau divided by external diameter divided by 2. Now please make sure that in this it is a hollow shaft, so in this the diameter ratio given is 3 by 5. That means 5, we can always assume that 5x being the external diameter and 3x being the internal diameter, right? So we'll transfer the same values into this equation and we'll get the value of x, because x is the only unknown, because T max will get from this equation, because P is also given and N is also given. From this equation we'll get T mean, and then we'll get T max. Then T max will transfer into this equation, and in this equation unknown is only x, and that value of x we can get. And once we will get the value of x, then we can find out the value of theta, what is asked in the question. So then we can always apply that T by J is equal to G into theta by L, or theta is equal to T into L divided by J into G, and in this we'll get the value of theta as in radian, right? So I hope that by this video you'll be very comfortable in solving these three numericals, right? So please solve these three numericals in a complete way on your own, and we'll discuss in detail, right? Thank you.